Hello! This is not a new Steve's Factory Manager version. Instead, I'm going to show you how to do a specific thing using Steve's Factory Manager. So a question I get a lot, and I've seen other YouTubers getting the question a lot as well when they have done things in Steve's Factory Manager, is how do you split some content evenly between containers? So for instance, if you want to supply coal to furnaces, how do you prevent all coal from going in the first one? And basically that is the question. And this is a direct response to Sice's tutorial on how to do it. So he did very well and showed you how to do it. So if you're new to Steve's Factory Manager, go ahead and check that video. I'll leave a link in the video description and an annotation on the screen. And just go ahead and watch that. However, if you have delved deeper into Steve's Factory Manager, I'm going to show you a few neat tricks on how you can do it more advanced, but in the end that allows you to expand further. So right, let's take a look on what this actually does. So we have a bunch of furnaces here and a chest. So now if I dump some coal in here, let's say 20, it's going to pick up 5 at a time and split them evenly between these furnaces like so. If I add a few like that, 4, it's not going to add them to the rest just because I don't have a full 5 yet. And if I do that, it's just going to pick 5 and be done with it. So that's one restriction with this build. But as we can see, it has evenly split it up in these different furnaces. Right, let's take a look. So Sice's approach was to just split it up using the flow controls, and that is it's a good approach, but it can get fairly big if you have a lot of elements. So this design is using more advanced things, using variables and loops and so on. So it's going to be a bit more complex, but it's rather easily expandable. So here in my furnaces variable, just a local variable here with inventory type, I've selected all the furnaces I want to use. And if you want to add more, just place them into your system and select them here, and you're halfway there already. And then I have another variable here called element, like so. And nothing selected, just that it's an inventory, like that. Okay, then I have a trigger here, triggering each second. Depending on when you want to do this, you of course can hook it up to something else. Then what I want to do, to make sure we actually can move everything, what I'm doing is looking in the chest, and I'm looking for 5 pieces of coal. And that's why when we have fewer than 5 pieces, it's going to leave them behind until we get a full set to move them to all of them, like so. But when we do have enough, what we want to do is use the for each loop. So what we're going to do is loop through every single element in the list here of furnaces and put them one by one into element. And then we pick out from the chest, we pick up 1 piece of coal and move it to the let's see, here we go. There you go, to the element, which means that we can just loop through them all and it's going to be done. So if I want another furnace, what I'll do is go here, select that one, and then simply change this one to 6 pieces of coal instead. And I can do that for 500 different furnaces if I would so like. So even though this might be a bit tricky to get your head around and a bit more complex things included, it's going to be very handy if you build huge systems and we still want to split it evenly. But as we saw, one restriction was that if you just have like 20 coal, for instance, in a system with 50 furnaces, it's not going to move anything at all, which might be a problem. We'll take a closer look on how to solve that later. However, when you work with furnaces, usually what you might want to do is, well, just keep them all loaded. You don't really care that it's evenly split, you just care that all of them have power at the same time. So as you can see here, all of these furnaces do have some coal in them, and I still have some coal there, but as soon as I pull this out, it's going to load it with another one, which makes sure that we always keep the power there. Of course, there's going to be a short delay when we don't have anything in it, but that doesn't matter, because then we will still have some heat here from the previous coal already. Right, so how is this set up? Well, if you use some more advanced mechanics without actually using more advanced commands, you can solve it as easy as this. And this one is also easily expandable. What you will have to do is, not that one, sorry, in the output you just select the furnaces you want and it's going to evenly distribute it between them. So how is this working? Well, nothing special with the trigger, and the input, there's nothing special with that either. We just grab from the chest, we grab everything we can find, basically. So grab everything you find in the chest, but here's the magic in the output. So we select them all, and if we define a multi-selection interaction, we tell it to run command once per target. This means that this output command is going to be executed individually for each and every furnace. The thing we can do there is then set a whitelist of 1 coal. This means that if we have a furnace without 1 coal, it's going to try to move 1 coal there. If there already is a coal in there, that means the whitelist is full and we can't move any further coal into that position, and therefore it's always going to keep 1. Of course, if I change this to 2, we will all of a sudden see that we will always keep 2 here in each of them, just because I had a coal here already. And you can increase that amount, of course, but that means that even if we have a bunch of coal here, it's not going to be moved in here, which this system allowed. So this system would move it, so if we add a ton of coal here, it's all going to be distributed between these, whereas this keeps it in the storage until it's actually needed, like that. So that's a quite clever thing that you can do with this multi-interaction thingy. So we have specific whitelist for the different furnaces. So, right, so we had this problem here that if we, well, like that, we need to actually have an even amount, like that, well, divisible by the amount of furnaces you have to get it to work. And if you don't like that, we can set it up like this. So now I'm using an emitter here to help me. That's going to help me count. And then here we had a chest like normal, and we have all the furnaces. Right. Okay, so what do we see here? Well, it's another version of the first one that we saw, but if we take a look first on what it does, if I add 1 coal, it disappeared. It was put into this furnace here. Right, if I add 2 coal, like that, they will disappear, and not be put in the first furnace, but actually in the second one and the third one. If I add, let's see, if I add 6 of them, we can see that it's going to have 2 here, 2 here, 2 here, 2 here, and just 1 there. And the next one, of course, if I add another one, is going to be put in this one. So it actually goes through them all and add them in a sequence. So if you want to keep the same amount in them all, but you want to move the coal as soon as you find something here, not as soon as you get the correct amount to be able to fill them all, then you can do it like this. So what we do here is having 2 variables here. This one with the furnaces is actually global this time, and we don't select the furnaces at all. But we're still going to use it for almost the same thing. And then we have the element that's still local, and nothing is still selected like that. So that part is the same. So what we do when we do the trigger here, we're going to check a redstone condition on this redstone emitter. If that's true, that's means that we still have furnaces to go through. So this is going to count the amount of furnaces we have left, basically. Right, so if we don't have any furnaces left, what we want to do is we want to set the furnaces to all our furnaces. Here is where you define the different containers that you want to add to the system there. Right, so that's that one. And then we want to set the emitter here to the amount we have left, which is 5. So this is actually going to be a limit. We can only set it to 15 as a maximum. So in this system, you can only have 15 containers. If you want to go higher than that, you can do it, but then you will have to detect if you're done in a more advanced way, which is possible, but like I said, it's going to be more advanced. Right, okay, so if we are out of furnaces, we just reload them all, and we go here. Right. Then we do like we did before, we just loop through them all, put them in element 1 by 1. What we want to do now is check that we actually have a piece of coal. So when we want to move a piece of coal, we first check that we do have it. And if so, we just move it. So we pick up 1 piece of coal, like before, and put it in the element like that. So nothing special here, we do the same thing there, but when we've done that, so when we moved 1 piece of coal, what we want to do is we want to mark that by decreasing the redstone signal by 1, and then we want to remove from the furnaces, we want to remove, this is too far down, we want to remove the element, which means that every time we successfully move a piece of coal, we're going to remove that furnace. Well, you're not scheduled for adding coal anymore, which means that next time we go into this system here, we're going to start where we left off, because the first one now is going to be the the first one, the previous time that we couldn't actually give any piece of coal. However, when we run out completely, then we are just going to refill them all and do it all over again. But like I said, we will have a limit here that we can only count to 15. But if you want to go really fancy, then you can actually detect if you're out of them by trying to check their items and trying to move things and see if something actually happened. But that's not something I'm going to go through here. So there we go. This is going to keep them evenly like that, but it's quite advanced. If you don't care about them waiting until you have the correct amount, then go with this setup here. Or if you just want to keep a specific amount there at all times, for instance 1 coal, then you can go with this system here. Or if all of these are too complex for what you need, and you're fine with adding some extra commands, then go and take a look at Size's video where he describes how to do it using split commands. That's about it. Good luck.